Hello and welcome to Lesson 5-7. Today we're going to look at inductive reasoning. We're going to look at using inductive reasoning in continuing number patterns, and we're going to look at writing rules for arithmetic sequences. So ultimately, inductive reasoning is nothing more than making a conclusion based on a pattern that you observe. And then a conclusion that you reach based on an inductive reasoning is what we call a conjecture. So what we're going to do is we're going to learn how to write an equation for the pattern that we were able to figure out. So when we look at example 1, it says use inductive reasoning to describe the number pattern. Then we're going to find the next two terms in the pattern. So typically what I like to do is I like to, addition, subtraction, multiplication, division, that stuff is probably the easiest approach. So when I look at 1 to 4, 4 to 7, 7 to 10, right away I notice that we are just adding 3 to go from 1 to 4. If I add 3 to 4, I get to 7. If I add 3 to 10, I end up with, or if I add 3 to 7, I end up with 10. So our pattern then was that we are adding 3 each time. So when we have to find our next two terms, 10 plus 3 is going to be 13, and then 13 plus 3 is 16. Now when I look at the second part here, I go from 3 to 12, 12 to 48, and 48 to 192. So right away, I recognize the relationship between 3 and 12 is I'm either adding 9 or I'm multiplying it by 4. So the relationship between 12 and 48 I see is multiplying by 4, and this holds true for all of these. So our pattern then is that we are multiplying by 4. So once I figure that out, if I go 192 times 4, I end up with 768. And then if I take 768 and I multiply that by 4, I end up with 3,072. Likewise, when I look at part C, it says I'm going from 2 to 4. So I could add 2, I could multiply by 2. That one's a little bit tricky. But when I go from 4 to 16, I know that that's a factor of 4, but to go from 16 to 256, the only way I can go from 16 to 256 is if I square that. So if I think about it, if I square 2, that will get me to 4. Squaring 4 gets me to 16, and squaring 16 gets me to 256. So here, we are going to square the previous term. My next two terms then would be 256 squared, which is 65,536. And if I square that term, then that's going to get me a pretty large number. And I'm going to write that down below. It's 4,294, 967, 296. Okay, now we're looking at part D. Part D, I'm going from 2 to 5, then 5 to 12 and a half. So I know that if I go 2 times 2 and a half, I get to 5. And I'm thinking about something with halves because I have this half here and then I have a quarter here. So if I go 5 times 2 and a half, I do end up with 12 and a half. So for this one, my pattern must be that we are multiplying by 2.5. Now I will tell you that the more you do of these, the easier this gets. So if I take 31.25 and I multiply that by 2.5, I end up with 78.125. And if I take that and I multiply it by 2.5, I end up with 195.3125. And then for my last part here, I'm noticing that I'm multiplying, or I'm changing my signs. So I must be doing something with a negative and most likely multiplying by a negative. So 2 times a negative 2 will get me to negative 4. If I go negative 4 times a negative 2, that will get me to a positive 8. 8 times a negative 2 gets me to a negative 16. So here we are multiplying everything by a negative 2. So my next two terms then would be negative 16 times negative 2 is a positive 32, and a positive 32 times a negative 2 is a negative 64. So when we look at a series of numbers, kind of like what we've been creating and we've been finding the next terms, okay, when we have a number pattern, okay, it puts it into what we call a sequence, okay? So each number in this sequence is what we call a term. So right here, you can see that I have one term, here's another term, here's another, here's another. If I come all the way down to the bottom, 1/7 is a term, 3/70 is a term, 9/700 is a term, 27/7,000 is a term. So the individual pieces are called terms, the whole thing together is a sequence. So as you progress in your math career, and what we're going to start in this section is we're going to talk about what we call an arithmetic sequence. So an arithmetic sequence is formed by adding the same number to each term. So the key word here is adding. The number you add each time is what we call the common difference. So when I look at my examples here, 4, and I'm going to add 2 to get to 6, 6 plus another 2 is 8, 8 plus 2 is 10. So I'm going to say D, or my common difference, is going to be 2. Likewise, when I look at this next one, I go from 1 to 1.5, 1.5 to 2. So here, D is going to be a half. And I can have a negative as well. So if I go from 20 to 17, 17 to 14, 14 to 11, here my common difference, or D, is a -3. So now for example 2, we're going to find the common difference. So to find the common difference, you're going to want to take like a second term minus the first term, or a fourth term minus the third term, and so on. So I'm going to take this 23 and I'm going to subtract the term that comes before it, which would be 11. Okay, and when I do this, I get 12. Now notice, I could do this on any numbers, so I could take 47 if I wanted to, and subtract 35 from it, and I'll also get 12. So once you establish what your pattern is, your common difference will be the same regardless of where you look. So your common difference then is 12. For part B, to go from 8 to 3, 3 to -2, -2 to -5, I'm just going to go 3 minus 8, and this here will give me a -5. And again, you can pick any two numbers that you want that are consecutive or right next to each other. Now once you know what your common difference is, and you know what your first term is, we can actually use a standard pattern, okay, to write what we call an arithmetic sequence. Okay, so this arithmetic sequence, this is something that you will need to know. It's written as A of n, which is your nth term, is equal to the first term, which is A, plus the term number minus 1 times your common difference. So essentially what happens is once I know what my first term is and I know what my common difference is, I can find any term that I want to without having to list the whole pattern out. So if I wanted to find the 100th term, I would go and I would plug in 100 in for that n, and I would add it to go 100 minus 1, which is 99, multiply it by that common difference that I would know, and then add it to my first term, and then I could find that 100th term. So we're going to see how to do that here in the next couple examples. So for example 3, we're going to write a function rule for the following terms. We're told that we have 7, 11, 15, and 19. The first thing that we're going to want to do is we are going to want to identify what our A term is, or the first term. So I'm going to say that A is equal to 7, and I get that from this right here. Then I'm going to want to look at my common difference. Well, my common difference, if I go 11 minus 7, this is going to give me 4. And if you remember, we have a formula that reads A of n equals A plus n minus 1 times D. So now all I have to do is I have to plug these numbers in. So I'm going to say the nth term, or A of n, is equal to my first term, which is 7, plus n minus 1 times my common difference of 4. Now if I really wanted to, I could go ahead and simplify this and distribute the 4 onto both. So that would give me 7 plus 4n minus 4, and I would collect my like terms. So I could also write this as A of n is equal to 4n plus 3, and this would get me any term in that sequence that I found. So if I want to just double check, this right here, this is my third term. If I plugged a 3 in for n, I would have 4 times 3, or 12, plus 3, and that would give me 15, which is exactly what I had right here. So this pattern double checks. So now for example 4, what we're going to do is we're going to find the 2nd, 5th, and 9th terms of each sequence. So in this case, I don't want to have to list out the whole thing, I only want specific terms. So because I want to find the 2nd term, I'm going to plug a 2 in for n. So I end up with 5 plus 2 minus 1 times 2, and I end up with 5 plus 1 times 2, which is 2, and I add that to 5, and I end up with 7. When I do the same thing for my 5th term, I have 5 plus 5 minus 1 times 2, and when I simplify that, I get 13, and again, I'm going to plug in my 9 for n, so I have 5 plus 9 minus 1 times 2, and this is going to give me 21. Now I'm going to go ahead and do the exact same thing for part B. So again, I want my 2nd term, so I have 7 plus 2 minus 1 times that negative 3. When I type that in, I end up with 4. When I plug in my 5 for my 5th term, I have 7 times a quantity of 5 minus 1 times a negative 3. And when you simplify that, you get a negative 5. And for my 9th term, I have 7 plus 9 minus 1 times a negative 3, and this here will give me a negative 17. And to finish up example 4, we have a of n. I still have to find my 2nd, 5th, and 9th term, so if you take a quick second and work this out on your own and then just compare and see what I got. Okay, so as you can see, I got negative 2, 7, and 19. And then I'm going to go ahead and do the bottom. So again, pause the video, try it on your own, and then see if you get the same thing. So for this bottom part, I ended up with 11.3, 26.3, and 46.3. Please let me know if you have any questions. Otherwise, I will see you in class. Thanks, and have a great day.